Okay, our objective is to continue talking about the multiplication counting principle, factorials, more about, how many ways there are to arrange, some more interesting things other than books or people sitting in a class. So that's the plan for today. I did not write the homework up on the board yet. I'm pretty sure I know what it is. I just want to make sure we get far enough. Okay? So starting with the warm-up that was up on the smart board. All right, number 1, it asked you for what color is the experimental and theoretical the exact same. So what color, Justin, is the exact same for both? Okay, can you explain that a little bit? Good. Good. So then our theoretical over here, in theory, we should be getting green 25% of the time. So if you're looking at the spinner, theoretically, okay, I know this one made you think a little bit, probability of getting green should be 25% of the time it lands on each color. Now, using the experiment, is that actually going to happen? Well, in this case it did, but typically it's not going to happen that way. There will be cases when theoretical and experimental are exactly the same. Charles? What do you mean? Oh, really? I wonder why. Okay. So next time I go to a math conference, maybe I'll just have you guys spin spinners or flip quarters all class. We'll see what happens. All right. Well, we'll work on that. Okay, number 2A. Briar, what'd you get for 2A? Okay. Okay, I'll come back to you for 2A, okay? Zach, did you get to 2B? Okay. Charles, 2B? Over? Good. 23 over 120 is our experimental probability of rolling a 6. Briar, still didn't find it? Okay, please make sure you have the warm-up out when we're going over it, okay? Annalise? No, theoretical. Not experimental, theoretical. Sean? Good. Okay, remember, theoretical, in theory, what should happen when you roll that number cube? So if you're rolling a regular number cube that has 6 sides, in theory, it should land on each number 1/6 of the time. And then the experimental probability, well, depends on what the experiment was and what happened. So here were the results for experimental. Annalise? But if it's off of the trials, it's experimental probability. The theoretical is just from that object what should happen. The only time you use the experiment results is for experimental probability. Okay? Okay, any other questions or comments on that? Okay, let's go to the second warm-up, which was number 2 in your notes on page 21. Okay, Briar, do you have this one? Okay, 2A. Good. Mary, 2B. Good, 1/2. 2C, Donatus. Okay, I will come back to you in a minute. Matt, 2D. Okay, that's letter C, that's fine. Letter C is 3 over 3, which is 1 over 1. That was the odds against getting an even number. Donatus, do you have 2D? What? Donatus, a little louder. 10 tens? Okay, yes, 10 times. Good. Donatus, you were really awake yesterday. Why are you so tired today? Donatus? You okay? Okay. You don't have to answer me. Okay, 10 times. All right, so that's for 2A through D. Annalise? Probability of rolling a 3 or a 4 on a number cube. So how many 3s are on a number cube? Okay. How many 4s are on a number cube? Okay, so that's 2 total over 6, which reduces to 1/3. Okay, so how many multiples of 3 are on a number cube? 2. So 2 out of 6 is the probability that you'll get a multiple of 3. It says you roll the number cube 30 times. So set up a proportion. You need to find what x is. Okay, there's always 6 sides on a number cube unless they say otherwise. Okay. Anyone else on the warm-up? Okay, let's go over your homework and then we'll finish up factorials. Okay, let's start with practice 6.8. Okay, you guys had 1 through 5 here. Sorry about all this jumping around here. Okay, Alyssa, we'll start with you on 6.8, number 1. No. I think you might have just counted something wrong. Justin? Good, 9 ways. Emma H, number 2. Good, 16 ways. Charles, number 3. Good, 12 ways. Jeremy, number 4. Good, 12 ways. Number 5, Emma M. Good, 60 ways. Okay, before I go to the next page, questions on those? Mary? Okay, well, if you accidentally did number 6, you should get 24. Did you get that? Okay, then you're good. Doing more math practice never hurts you. Annalise? Number 2. Okay, number 2 you should have had set up as well, there's a minivan. Oh, I see what you're saying. Yeah, they really meant you have all those car options and then all those colors. So sedan, you're right though, Charles. The wording is always weird with these book problems. I agree. You should see mine. It's a mess because I tried to make the tree diagram just in case you guys had questions. Anyways, Annalise, do you understand this? Okay. 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 And then 4 branches for each. You could also do 4 times 4, which is 16. Briar, is that a hand? Okay. Anyone else on that one, Matt? Okay. Number 3. Okay. Okay. Number 3. So the top of your tree diagram for number 3, Matt, you didn't? Okay. What did you multiply then? I'll do it your way. You mean khakis? Okay, that's okay. I was all confused. So Matt, it should be 3 times 2 times 2. Okay. Oh, you knew what that word was. Okay. Next time I'll read them to you before you do your homework. So basically, t-shirt, button-down shirt, okay, or sweater. So you have 3 options for your shirt. Then you have jeans or khakis for your bottoms. So that's 2. And then you have either a red coat or a blue coat. That's 2. That's why you messed up. Yeah, but pants have nothing to do with shirts. Remember that. I hope that you're going to have some kind of shirt on and then some kind of pants on and then also a coat. Okay. On the test, I always type them so the wording is much better. Sometimes these things are mushed together. Charles? Okay, but like I told Matt, shirts go with shirts. Yeah, I know, but shirts go with shirts, pants go with pants, coats go with coat. Yeah, that's why. All right, let's go to page 91. You had 1 to 5 on there? Is it 92? Oh, sorry, 92. My fault. I wrote the wrong one on the board. Jeremy, what's wrong? Sorry, guys. No, that's my fault. Sorry. 92. I get all confused with these pages sometimes. Okay. Number 1. Zach, we'll start with you here. Number 1. Yep, you're good. What about experimental? Perfect. So theoretical, what should happen? Experimental, what happens after you actually do an experiment? You may also have the favorable over total for theoretical, number of successes over number of trials for experimental. You don't have to, though. Mary? Yep, that's perfect. Perfect. Okay. That's fine. That's fine. No, we're on that one right now. Okay, Breyer, 2A. Good. Sean, 2B. Good. 303 over 1,000. Annalise, number 3. Good. So 4/9. Okay, 4 has an A, B, and a C. So 4A, Justin. Good. 1/6. Matt, 4B. Good. Jeremy, 4C. Perfect. Donatus, 5A. You what? Oh, I told you guys 92 yesterday, right, in class? Okay. No, it's wrong up there. Okay. Alyssa, 5A. Good. 2/3. Emma H, 5B. Good. Charles, 5C. Perfect. I mean, you guys are on a roll. Yeah. I know. Wow. Very good. Annalise? You would lose half a point on a test. Always simplify. Always. Zach? Yep. The odds in favor and odds against, I would keep those always written as a ratio, because that's how you'll always see odds, as a ratio. Probability, like theoretical or experimental, you will see as a decimal, fraction, or a percent. Okay, good question. Yeah. I agree. It's just a math thing. Probably. Okay, any questions on homework? All right, let's go back to the notes. So we are in our notes here. Page 22 is where we left off. Calculator open, because we'll need that in a second. Okay, while you're getting page 22 of your notes, who can remind us, what is a factorial? Who can remind us? Fryer, what's a factorial? Good. Awesome. So number multiplied from x down to 1. Sean, what else can you say about it? Awesome. When do we use a factorial? How do we know when to use it, Charles? Good. You still have to make sure that you take that last object into consideration. You're exactly right. Multiplying by 1 means nothing. But I'll show you today what they actually mean by that with this problem. Where on your calculator is the factorial button? Emma H? Awesome. Math, PRB, number 4. Okay? Mary? Yes, it does. Charles? Good. I'm glad you found yours. Good. Okay. Oh, gosh, that's funny. Yeah, we're not going to scream the numbers, okay? Okay, Donatus, did you find it on yours? Factorial button? We did this yesterday, Donatus. Did you find it when we did this? Okay. All right, so example 2 on page 22. So it asks us, how many different ways can you arrange 8 books on a shelf? So of course we're going to use factorial, but let me show you the meaning behind this. 1, 2, 3, 4, 5, 6, 7, 8. So yes, we're going to use factorial. Here's why it works this way. Okay, so let's say that these lines that I drew are my bookshelves, and each line represents one spot on the bookshelf, okay? The first time you try to go to find a home for the book, how many spots are there? The first time you find a home for the book. Jeremy? Good, 8. So I'm going to put an 8 down here, and I'm going to decide to put the book right here. There's my book, okay? The second time you put a book down, how many homes are there for this book, Mary? 7. So I'm going to put this book over here. There were 7 homes for it. We found 1. The third time you put a book down, how many homes are there, Emma? Good, 6. I'm going to put it up here. The next time, which is the 4th time we put a book down, how many spots are there? Annalise? Good, 5. I'm going to put the book over here. The 5th time we put a book down, how many spots are there? Jeremy? 4. I'm going to put it right here. Okay, do you guys get the point? Next time there's 3. The next time there's 2 spots. And the last time, which is to kind of answer Charles' question, the last time you try to find a spot for a book, how many homes are there, Charles? Yeah. I know, but you can't forget about the last book. Okay, you have to put that last book down. The whole multiplying thing means nothing, but when you're placing objects, like if you were placing objects at a store and you didn't place the last one, that makes a big difference. So you're right with your saying, but there's other reasons that you have to put it down. Okay? This is kind of like the proof behind factorials. This is why it works the way it does when you are arranging objects. So no, you don't have to do all that. You just have to put 8 factorial. How many ways are there to arrange all 8 pre-algebra books on a shelf? Emma M? Emma M? Emma M? Good, 40,320 ways. Oh, we'd be here. We'd be here all day doing this. Charles? Yep. Nuh-uh. Oh, is that weird? Why? But did you tell her that you learned that yesterday? Yeah, but I would have been proud of you because that's something you just learned yesterday. Okay, well, I'm telling you that that's awesome. Don't repeat that. Hey, let's be nice. Let's be nice. But I'm impressed that you transferred that to your 6th grade test. Well, they're doing it, of course they're not doing it this way. And then you put 12, or 24, I mean. Yeah. Did you put that? Okay. Man. All right. Questions or these comments? Let's hold that. Annalise, is a question? Go ahead. That's what I just explained. Like, so the first time you put a book down, there's 8 different spots. Okay, times the second time you put a book down, there's 7 empty spots. You always multiply. That's how you find how many ways there are to arrange things. You don't add them because there's many more than 8 plus 7 plus 6 plus 5 ways to arrange them. Okay? The first time you put a book down, basically, there's 8 different spots. So it doesn't have to be one particular spot. The second time, there are 7 different spots. You're multiplying it because there's 7 different spots. There are 7 different ways. Never add them. You're finding the number of arrangements. You could switch these up millions of ways. Well, not millions, thousands of ways. I don't know if that helps, but that's why I went through that whole explanation there of how to put them down. That didn't help. Yeah, When you're finding how to arrange things, Annalise, you always have to multiply because you're always moving things around. Always. It's like that ABC thing, trying to arrange them. We wrote them out 6 times, but it's the same thing as 3 times 2 times 1. It's the same thing as listing them all out. Okay? We kind of did that yesterday too. I don't know how else to say it because us writing that out yesterday and drawing this should make more sense with that. Always multiply. Sean? Ooh, we're getting to that. So hold on. We're getting to that. No, you could also do it another way. You can do that, Adam. You're correct. There's another way. We're going to do that. I'm glad you asked. In about 2 questions, we're going to do that. Charles? Yeah. We're also going to, I'll show you how to figure that out. All right, let's go to the next one. Okay, example 3. Okay, using the counting principle, it says, you roll a red and a blue number cube. Okay, use the counting principle to find the different outcomes that are possible. So we're using the counting principle. So ready? If you're using the counting principle, you're always multiplying. If we roll a red and then we roll a blue, okay? What'd you say? Oh, that is weird. How many options do we have for the red number cube? Mary? 6 times, because we're using the counting principle. How many options are there for the blue? Sean? Good, 6. So 6 times 6? 36. I don't know. So on this one, there's 36 possible outcomes. Now, we've actually done a problem like this using a tree diagram. So Annalise, if it helps to answer your question this way, think about making a tree diagram and listing all the possible outcomes. There's going to be 36 outcomes by making 1 at the top, your red number cube with 6 branches, and then off of each of those 6 branches, 6 more branches off of each to represent the blue. So you're multiplying because there's a lot of outcomes. Okay, it's the same thing as drawing your tree diagram, but that's a pain. You don't want to draw all those branches, okay, for something like that. No. You multiply how many options or outcomes there are for each item. Charles. Okay. Hold those comments for now. Okay, that's good. That's exciting. Okay, let's go to example 4, which kind of talks about what Sean and Charles brought up. And then I made up some other examples we're going to add in. Okay, example 4. A combination lock has 40 numbers on its dial. To open the lock, you must turn the dial to the right to the first number, left to the second number, and then right to the third number. You randomly choose 3 numbers on a lock. What is the probability that you choose the correct combination? Okay, so my first question to you is, this is just regular probability. Okay, yes, there's going to be multiplication counting principle in it, but when we find regular probability, our fraction is always what over what? For regular probability, our fraction is always what over what? Friar? Okay, so probability we're going to get the correct combination. Totals on the bottom. What goes on the top? Matt? Good, favorable. Okay, so write that down. So my first question is, okay, let's start with the total. If there are 40 numbers on the dial, okay, but of course there's only 3 options, okay, what do you think the total is going to be? There's 40 total numbers, okay, that are on the dial. How do we find the total? If we only have 3 numbers, but there's 40 options. Zach? 40 times what? No? Annalise? 40, just 40? Nope. Mary? Nope. Adam? Nope. Matt? Come on. No, you're so close. No, you're so close. Charles? No? That's for the next one we're going to do, what you just said. Not the next one I'm making up. It's not on the paper. Sean? Okay, go ahead. 4? Where 4 come from? Yes. Okay, 40 times 40 times 40. Why? Why is that how you find the total, Alyssa? Yeah, there's 3 numbers. So ready? The first time you pick a number for your locker combination, you have 40 numbers to pick. Okay? The second time you pick a number for your locker, you're allowed to have repeats. Why not? Your combination could be 3, 3, 3 for all we care, right? So you still have, that would probably be stupid, but you could have it. Okay? 40 options for the second number, 40 options for the third number. You're allowed to have repeats. For each number, you have 40 options. It's not 40 times 3 because you're figuring out, just like the whole book thing, how many options do you have for each spot? This is the multiplication counting principle. You're figuring out how many options we have for locker combinations. Charles? Oh, yes, me too. Now, another trick question. What's the favorable? What's the favorable? Zach, what do you think? Why 1? You're right, but okay, so basically there's one correct way to open this locker, right? There's one correct combination. Even if you use the same numbers, there's still one way to open up this person's locker. Okay, it's like trying to break into someone's email account or Facebook account, trying to get their password exactly correct. Okay, I'm not recommending it. Okay, but favorable is 1. It's easy once we talk through it. There's one way to get this right. Annalise. That's why there's 3 spots. If favorable was 3, then you would be telling me that there's 3 ways to open up the locker combination. There's not 3 ways. There's one way to open that locker. We don't care that there's 3 numbers. You basically, that 1 means you have to get all 3 numbers right to open up that locker. If you get 2 numbers right out of the 3, that locker is not going to open. So no, not 3. It has to be 1. There's one way. That's it. You have to be perfect to get it open. Adam. Thank you. That's where I was getting. Okay. 1 over 64,000 is the probability that you're going to get that locker opened. Okay, so this one was can have repeats. So this answer was if you're allowed to repeat the number on your locker combination. So guess what I'm going to have us do now? If you can't repeat. So let's do probability that we're going to find the correct combination, correct combo, no repeating numbers this time. Okay? So same question, but I'm telling you, you're not allowed to repeat your locker combination. So probability that we're going to get the correct combination, but no repeats. So it's still favorable over total. So I'm not allowed to repeat it. Write down what you think, how you think we have to find the total. Write down how you think we have to find the total if you can't have repeats. Good job, Donatus. That's the same thing as the first one. Yep. Where's your answer? Good. Good, perfect. 1 over though. 1 over it. Okay, perfect. Oh no. Oh, gotcha. I was looking over there. Thinking? Okay. Make sure you're taking notes. Nope, do that again. You're close. All right, math, there's not repeats. So how do we find the total? No. It's partly that. So, Matt, listen to this. There's only 3 numbers. So if it's 40 factorial, that's like you're telling me. Good. Good. So it's just like factorial because you're going there, okay? But you can't have a repeat. So the first time you pick a number, there's 40 options. If you choose that number, the second time you pick a number, there's now only 39 numbers to choose from because you're not allowed to repeat. Third time you get one, there's 38 because you've already chosen 2 and you can't repeat. Justin? Go for it. Good, and 1 over that, right, Justin? Okay. All right, so if you can't have repeats, there's the probability that you're going to get into someone's locker or figure out their code or password. Jeremy? What's your other way? Oh, maybe sometimes, but that's no fun for math, right? Mm-mm. Sean? We're in letters. We're getting there. Hold on. I promise you we're getting there. MAH question? Well, technically. All right. I want you to flip over to the, oh, you don't have a, okay. Let me have you go to the inside cover of your note packet. We're going to do 2 more problems. So go to like the orange inside page or your notebook, whatever you prefer. Yeah. All right, so here's what we're going to do first. You don't have to write this unless you want to. Okay, now, this is kind of like what Sean was asking. We now need to find the probability. We're trying to break into someone's account, okay? What's the probability of creating a password with no repeats if there's 2 letters and 2 numbers? So you guys are trying to figure out my password for my grade book because you all want to have over 100%, okay? So pretend like my password has 2 letters and 2 numbers, but I can't repeat them. Okay, let's talk through this. First question is, how many lines am I drawing? Sean, how many lines am I drawing? 4. Well, I'm going to tell you, we're going to talk about that. Okay, hold on. Okay, first thing, 2 letters. If the first 2 things have to be letters, but no repeats, how many options do we have for this part of our password? Justin? Good, 26 options. Times, we're still using the multiplication counting principle. How many options do we have for this line? Alyssa? Good, 25. Okay, times, the next one's a number. So, I want you guys to see if I want to see if you know this. Zach, how many? Why 10? Good. There's 10 digits that we can use, okay? Digits, okay? A number, okay? So we're using digits here, okay? So we're assuming that it's just going to be a digit. We have 0 through 9. There's 10 digits, okay? Typically, your password, it goes by, you know, what's the next number? It's not 32, it's 3 and then 2, okay? You have to get that password right. So if no repeats, how many numbers do we have for the next spot? Charles? Good. Well, we're not including pi, but you're right. All right. Okay, hold on, Charles. Okay, how many options do we have? So what's 26 times 25 times 9 times 10? Annalise? Awesome. It doesn't matter. Order doesn't matter. Doesn't matter. Yeah, it should on this one, yeah, but you can multiply them in any order you want. Mary? No, because this one doesn't ask you what is the probability of you getting the correct password. It just asks you, well, actually, this should say, I'm sorry, this should actually say how many options are there or how many combinations are there. I will be clear on that. You'll know the difference. So on a test, if it was like the previous one, it would say, what is the probability of finding the correct password of, okay? If not, if it was like this, Mary, it would say, how many options are there for passwords with no repeats if there are 2 letters and 2 numbers, okay? That's not worded correctly. Same with this one. It should say how many combinations or how many options are there. So let's do this the same thing, but how many possibilities of passwords are there, okay? There's no restrictions this time, which means you're allowed to have repeats. 2 letters, 2 numbers, you're allowed to have repeats. 2 letters, 2 numbers, we're allowed to have repeats. So no restrictions means you're allowed to have repeats. Same thing. How many different passwords are there? Briar, how do we do this? No, we're doing English. We're doing English. 26 times. Briar, times. Good. Times, Briar. Times. Awesome. Yep. Okay, so how many different passwords are there? Alyssa? Good. 67,600. Charles? No, me either. So there's that many options. So if the question was, what's the probability you're going to find the correct password? How would you change that answer if it was, what's the probability you're going to find the correct password, Adam? Good. It'd be 1 over 67,600. Okay, all right, let's do this for, no, let's skip this for now, sorry. Okay, let's go back to your notes. Okay, I needed to show you one more concept here. Sorry, I know I keep flipping you around today. Page 22, because I like to add in those harder problems, that's why. All right, so example 5, last part of today's notes. We need to figure out how many ways there are to arrange letters in a word. Now, to me, this question's kind of weird. What I try to tell you is think of when you were a little kid and you had those magnetic letters that you put on the fridge. So if I gave, like my niece is 2, so if I gave her 5 letters, the E, Q, U, A, and L, and I wanted her to try to spell equal with that, it's probably not going to happen, okay? But our job is to find how many ways there are to arrange all those letters in the word equal. So, are there any repeats in the word equal? Like, are there any letters that repeat? No. So, anyone have any idea? How would we find how many ways there are to arrange the letters in the word equal? Adam? Why? Yeah, it's just like the books. Awesome. I'm glad you remembered that. So, Justin, how many ways are there to arrange? Good. There are 120 ways to arrange all the letters in the word equal. The question I get every year is, well, why would you do this? This is just application so you understand why else we use factorial. It doesn't have to be for words. It could be for objects. It's just easier to teach it from this. Emma? Yeah. Yeah. Okay, let's go to letter B. What's different about B besides it's a different word? What's different? Alyssa? Good. It has a repeat. So here's what you do. 4 factorial, okay, is the total. There are a total of 4 factorial letters. So 4 factorial ways to arrange all of them. Now, when there's a repeat, you have to divide by the letter that's repeated and how many there are of that letter. Because there's 2 T's, so that T is the exact same thing. Since there's 2 of them, we divide by 4 factorial. Now, since you divide by the letter that's repeated and how many there are of that number, you can either write this out and do this in your head, 4 times 3 times 2 times 1, divided by 2 times 1, you get 12, or you can use your calculator and take 4 factorial divided by 2 factorial. So go ahead and take your calculator. I want you to type in 4 math PRB number 4 divided by 2 Math PRB, number 4, hit enter. Make sure you get 12. No, can't. There's 4 spots. So like there's still 4 things that you're arranging, but there's a repeat and there's 2 T's. So it's the same thing. Correct. The T is a T is a T. Okay, Annalise. Yeah, can I do one more before you ask what you're going to ask? Okay. All right, let's do one more. Okay, level. I need to show you this one because this is the only only other difference that we have on these problems. So the word level, one more time, what's different about the word level? Sean? It has 2 repeats. So there's a total of 5 letters in the word level. Okay, so it's kind of like saying you have 2 objects that are the same. What do you think we divide by on this one, though? Briar? No, careful. And I'll tell you why. It's very different. Jeremy? Good. 2 factorial times 2 factorial. So let me tell you why Briar was not right with that, how he said it. There's 2 E's, there's 2 L's. Okay. Is 4 factorial equal to 2 factorial? Is 4 factorial equal to 2 factorial times 2 factorial? No. What is 4 factorial? 24. What's 2 factorial times 2 factorial? Annalise? 4. Briar, do you understand what I'm saying? These are extremely different. Don't mush them together. On your calculator, if you're putting this on your calculator, you have to use parentheses. So you have to do 5 factorial divided by 2 factorial times 2 factorial in parentheses. If you don't use parentheses, it's not going to work. Remember, the E's and the L's still have to be in a spot, but they're the same thing even if we flip-flop them. That's why you're dividing by those spots, the 2 factorial and the 2 factorial. Sorry, thank you. Okay, did everyone get an answer? Did you get an answer? Are you doing it in your head? No, it's not 5. Alyssa, what'd you get? Charles, what'd you get? Okay, hold on. Sean, what'd you get? Mary, what'd you get? Justin, what'd you get? Okay, you should all get 30. Okay, Charles, hold that thought for now, okay? Hold that thought for a second. Okay. Emma. You did what? Oh, you did the word multiply. What did you get? Good. If you guys are ahead of me and did the word multiply, that's correct. All right, so not to like make you guys crazy here, but I was going to give you the word Mississippi, but maybe we'll do that tomorrow. All right, Annalise, real quick. Because there's repeats. So since there's 2 L's, okay, you still have to have those L's in an object, but since they're the same, you can flip-flop them. So you have to divide by that extra spot because it's the same thing whether you have this L here or here and vice versa. There's 2 E's. So when you arrange them, it doesn't matter if they're in this E is here or this E is here. It means the exact same thing. So you have to divide by the repeat. Charles? It is. It is. All right, open up your homework packet because we got to get moving here. So, okay, your homework is page 92. Shh, listen, numbers 6 to 13, and shh, you're okay, Jeremy. Page 91. Numbers 1 to 15. The only ones that you might be a little confused on are numbers 1, 2, and 3 on page 91, but I want you guys to try to figure it out. Okay, so if you're a little iffy on those, just remember that I warned you about that. I know a couple of you might be asking me tomorrow, but that's okay. So just those 2 assignments. Sean? Wait, what? Yeah, I know. That's why I said just do 1 to 15. I did that on purpose. Just do 1 to 15. No, just do the front. Page 91, just do the front, okay? All right, everyone good? Okay, I'm late again today, sorry. I get too excited about teaching factorial.